and share it on Zoom so that I don't forget. And over here to the quiz. To talk about the quiz problem here, I'll do something a little bit different. Rather than typing in all these problems like I've done before, I'm gonna switch over to, I have two terminal windows open here, and we'll do things in a slightly more nicer, more automatic way. In the top window up here, I'm in my CS 143 folder inside the topic 3, where there's the quiz file right here. And I'll open that up. It's a LaTeX file for those of you who've used that before. And I'm just going to find the quiz problem. I'll press / down here. And I know the letters QUIZ are contained in the first quiz problem. So I'll hit enter. And this is the contents of the first quiz problem right here. And what I'm going to do is I'm going to copy and paste from the top terminal down into the bottom terminal in order to run things. So just start with our first line like this. And we're in the quiz folder. Now the first interesting line right here, creating this foo variable like that, hit enter. And the important thing to recognize here is that because it's in the single quotes, we do not do any of the expansion right here. And so if I echo this out, and again, it's always safe to echo something. Echo is idempotent. We'll get this exactly as it's written right here, not doing the processing of the echo command. On the next line down here, the third line of the quiz, I could copy and paste all of these things one at a time, but with my mouse right now, if I try to do them all at once, you can see I'm also getting these numbers over here in term and like the line numbers. In Vim, it's you can turn off the line numbers, set number, set no number, number turns them on, no number turns them off. And so normally when I'm working on things, I like to have the line numbers, makes it easy to see what line I'm referring to. But then if I need to copy and paste using the mouse for whatever reason, then that makes it easier to do so. So now I can copy and paste that whole thing down here and hit enter. All that got put inside of the quiz file. Again, you can cat things out. That's always a safe thing to do. It is idempotent. And you can see up here where the type of input redirection that we had over here, there was no quotation marks up here, so it did not try to do any of the so it did try to do the $ substitutions down here. Up here in the quiz and on your paper, it should say $foo, but down here, if you actually look at the contents of the file, you'll notice that it did the substitution down here. And so this foo variable right here, even though it's defined, it's not going to mean anything for us. And so then the very last step for us on this is to, I guess 2 steps, actually run that file and then type ls. And here's our 2 answers, ls, else, and quiz.sh. Again, because up here, the substitution happened in the EOF case. It happened during the input redirection, but it did not happen up above. It did not happen on this line right here. That's why we don't match either of these if conditions. Neither of these are going to match. And we come down and do this else statement here. Any questions about this first problem? Yeah, Judy. This line right here, or this?
Yes.
This one. So yeah, the question is right here, we're defining this variable foo and setting it equal to ola. And the question is, why are we not substituting in ola right here? Yeah, it's a great question. And the answer is how this input redirection works. When we do the input redirection, then here, because there are no quotation marks around this EOF, this is first interpreted as a string, as if it was inside of double quotation marks. And it's eventually we're going to pass it to the shell and interpret it as shell code. But at this point, it doesn't know that it's shellcode. It's just a string. It has nothing special about it. And so when it sees this $foo right here, it's not interpreting this $foo variable right here. It's interpreting this one up here, because this is the foo variable that is available at this point in the shell program. We can verify that by coming down into my bottom terminal. And here with this cat quiz.sh, you can see that it did the substitution right here and right here for this first foo variable up here. I'm going to use in the bottom terminal right now, press the up arrow a couple times until we get back to this cat command like this. So we have this multi-line command. I'm going to jump all the way to the beginning up here on this first line, and I'm going to change this EOF to be inside of quotation marks like this, so that it's like it's a single quotation mark string that we're inputting, and hit enter. And now if I cat the output of that, now it did not do the substitution of the $foo right here. And so now when we interpret this entire script right here, this $foo will be substituted with that. Yeah, so it's very tricky. There's a lot of very subtle things going on here. There are some things in the shell that you just never get used to. This is one of the things that you eventually get used to, but it does take a while to get used to it. And it's a legitimately weird thing. If people were designing the shell from scratch today, we would try to avoid this kind of behavior because it's very confusing. But we have to maintain our backwards compatibility, so we have to keep what we have. And so we have to understand the weird, confusing edge cases like this. But good question. Problem 2. Down here, I'm going to type reset, clear off our screen. I'm going to go to problem 2 in Vim. You can go to the next paragraph by using the curly brace. And I always structure all of my code so that the paragraphs are like meaningful things that I want to jump between. So the curly braces in my LaTeX document happen to take me from one problem to the next. Paragraph being an empty line. Yes. Question is, do I write my LaTeX in Vim? And there is absolutely nothing that I do not write in Vim. So yeah. Okay. Yeah, I know a lot of people like using the overleaf. I hate having to rely on web-based things. I'm often not connected to the internet, and so certainly would not want to use that. So problem 1, just resetting the problem right there. Now our foo equals hola. So it's a simple thing. It's just going to be equal to hola, nothing to interpret right here. Echo hello into foo. This is the first starting to get confusing thing, because we have 2 different foos right here, 2 different foos. This foo right here is a file name foo. If I type ls, we'll see this one right here. That one corresponds to this foo. It exists as a file. And if I did cat foo, this cat will get me the contents of this file, which gets me the hello up here. Again, cat, ls, both idempotent, not going to affect my output of the quiz at all. This foo variable up here, we would access that with the $foo, and that will give me the hola. So very important to pay attention to the difference between files and variables in the shell. And now we have this one super complicated line down here. We'll go ahead and run this line, and then we'll talk about the output. So run that and cat foo right here. First of all, before I hit enter, we know that this is going to be affecting the foo file, whatever this line is going to do, because we have output redirection right here going into the foo file. And then the very last line, cat foo, is going to be displaying the contents of the foo file. And here, the contents of the foo file contain only the word hello and do not contain anything else. So now let's talk about why that's the case. So up here, when we did cat foo, it contained the hello line. And then down here, we had the possibility of adding something more to this file. We had the possibility of adding more to the foo file depending on how this right here got evaluated. The square bracket, again, is just an ordinary shell command. And in this case, it happens to be checking if $foo is equal to hello. In this case, $foo is equal to hola. And so this right here evaluates to false. Again, when something evaluates to false, the way we keep track of that in the shell is through the exit code of the program. And you can always access the exit code of the most recent program using the $? A non-zero value means false, and a zero value means true. So this over here evaluated to false, and so because this evaluated to false, we did not run this command over here. We did not output anything to add to the foo file. If I were to change this command, so I'll press the up arrow, coming back to this command, replacing the double and right here with the double or sign. Now the double or sign is going to say, if this thing is false, then do the thing on the right. If I hit enter now and redo the cat, then it adds the hola to the foo file. Right here, this echo command prints out hola, and with the output redirection, it adds it to the foo file. If we run that a couple times and do the cat, we can see there's a couple of these holas down here. In most programming languages, so things like Python, C, C++, Java, anything besides the shell, this would be considered extremely ugly and bad style, and all of your coworkers would hate you if you're doing things like this in an ordinary programming language. In the shell, though, because the shell gets embedded into weird things like Docker files, sometimes there's no way around doing weird things like this in the shell. And so people just suck it up and have to deal with it and interpret it in their head or work it out on pencil and paper when they come to these things. There's just certain situations where you can't avoid this in the shell. Any questions about number 2? Hannah. So the question is, what happens without the parentheses? What the parentheses are doing is they're making the output redirection apply to this entire thing right here. If I were to take away the parentheses, then what's going to happen is that the output redirection will so the most mathematically precise, but maybe the least informative way of saying this is that the double bar operations has the higher order of precedence, that this is gonna, this divides these two statements in two. And so this statement only applies to this one right here now. If I hit enter, I think that'll still happen to be doing the same thing because this causes this entire thing over here to be run. And if we change that to the ampersand like this, then that still causes this entire thing over here not to be run. So the output happens to be the same in this case with or without the parentheses. In general, the parentheses can affect things. So for example, let's go ahead and remove that foo file and change this to, if we have echo A and echo B like this, you'll see that the A over here, the thing on the left, got output to the screen. The thing on the right had the output redirection applied to it, cat foo like that. So this is all together as one operation. But if I were to combine all of this inside of parentheses, then you see that nothing's getting output to the screen and the A and the B are getting output into the file. Yes, okay.
So if I have the same thing, but instead of redirecting it, I like send it to a different folder. When I ls it, that folder shows up, but I can't actually cat into it.
So let's say we had a folder like this. Mcdir bar. So it never makes sense to run cat on a folder, that you'll get an error message. You can only run cat on a file. If we were to do something like this and now bar slash foo, we'll change the message over here to be C and D. You can cat the contents of that file just fine. You just have to provide the full relative path that's going to reach that location from your current location.
Well, I'm saying like instead, so like on the line where you said and echo $foo and then redirect it to foo. If I redirect it to like a different file instead, like if the left part still evaluates, like it doesn't do anything, but when I do ls is my blacked out and at the end.
So your question is, if this evaluates to false over here, will this file be created?
Yeah.
I don't know, actually. So let's test that out. So false, and echo test. The false over here. So this is definitely not going to be created because this thing over here is not going to get run when false runs. So do that, type ls. There's no false. Up arrow, put this whole thing around. My guess before I actually sit and run this is that this is just going to have no output. No output still going to cause the file to be created over here. And it is created. It's just going to have nothing inside of it. Did that answer your question? Good questions. Any other questions so far? Okay, number 3. I skipped too far. I did. Reset up here. Copy you. Paste you. Copy you. So let's see. So it's going on to multiple screens right here. I'll just zoom out real quick so that I can copy with my mouse multiple things at once, paste all that. Oh, it's 2 different commands. So paste the first one, then paste the second one, then zoom back in up here. And then the key thing about this problem is that we're having ordinary functions, not the square bracket function inside the if statement. And this, the grep function or the grep executable is going to return a success error code whenever the regular expression over here matches inside the file. The error expression, error is not contained in this file, so that will not match. Warning is contained in the file, so warning will match. Info is also contained in the file, so info will also match. But the key thing is here, we will never actually run this one down here because it's an elif right here. And so we do this and we won't keep going. So when I come down and do the shquiz.sh, let's run ls. So we have the logs in the quiz.sh, quiz.sh, and then ls again. We get the warning, but no info because we ran this if statement right here. But because this is an elif, we don't run this one as well. If that was just an if, we would run it. But it's not, it's an elif, so we don't run it. Question? Question is, what is this /dev /null? The answer is that, so let's say I do cat logs like this. By default, the cat program will output to standard out to the terminal like this. Cat logs pipe grep info like this. This gives me all of the infos. And adding this over here, it actually doesn't change the answer to the problem in any way because the answer to the problem only depends on the ls, and output redirection never changes your status code on your programs, never changes the exit code, so it never changes how the if statements behave. This is only going to change what the output is from these programs is doing, where it's going. And the output redirection into /dev/null says don't print it to the screen, save it to this special file /dev/null. Everything in the /dev folder is a special file, and this special file just means that the operating system is not going to do anything with whatever you write to that. It's not going to save it to the hard drive. It's not going to do anything with it. If you do ls/dev, you can see there's lots of special files. We're not going to talk too much about any of these, but these are every device that's connected to a Linux computer or Unix computer is always represented by a file in the /dev folder, and you always interact with it by outputting to the device. And so if I wanted to make this play some music, I could do something like echo some music commands into /dev/ the speakers, and then the IT people would hear some weird stuff going on down there. But we don't have the speakers next to us over here, so nothing would happen that we could see. That answer your question? Any other questions on problem number 3? Yes.
There's no file that you can
There is a file /dev/null. So ls/dev/null. This file does exist. Here's the permissions to it. It's owned by root. Everybody can read and write to it. But whatever we write to it, there's no way to like get anything back out of it. If I do, yeah, cat/dev/null, you can see there's nothing inside of it. Echo hello into /dev/null, cat it again, there's nothing inside of it. Yes.
is there a reason to not exclude that action, which is the info?
Why this is not happening? Yeah, so the reason, this is a great question. The reason, or the question is that here when we have this grep info right here, if I just come down here and say cat logs pipe grep info, like that, we can see it does in fact print out a bunch of things. And if we check out the status code, that means it was successful. So this, this command right here would return a successful error code. The key problem here, though, is that this command never actually gets run. Each of these, this elif means that only one of these can be run. And here, this elif is like an else with an if inside it. And so because we do this, we don't go inside this else statement down here. Yeah, so a very subtle thing there. Easy to get tricked. Last problem. Copy the first line, our familiar foo equals ola, and then a whole bunch of random if statement condition like that. Hit enter. Nothing special going on with the or sorry, because we have the quotation marks right here. Remember, the quotation marks right here means that this is the literal string and no substitution is going to happen. And so down here, when we have this $foo, that means we don't substitute it with the foo right here like we did up above. So now if I do cat quiz.sh, we can see that there is in fact the $foo right here and not the ola from up here. So now when I run the sh quiz file, then the foo right here will refer to this foo, which will be salve, which is not equal to ola. And then the bar right here will not be, that will be equal to hello, which is not equal to salve. And so when we evaluate all of those things, we get that it did, this whole thing up here did evaluate to true, and we do go inside and touch the if file. Any questions about that problem or any of the other problems? Okay, total up your score and get the papers up to me. Any others? Yeah, the question is, can you get these back? And the answer is I have them all just up in my office. So come by my office sometime and I'll give you back your old ones if you want them. Okay, today we have this other notes packet. We'll go through that in a minute here. Before we do that though, I want to do some quick announcements. So the announcements are on our topic 3 folder on GitHub. And I'm gonna come down to the bottom here. And for this week's assignment, and class on Friday, I think it makes the most sense for us if rather than have like a working period and a lab to work on, we won't have a lab this week, and instead I will go over some of the more difficult parts, the weird things that can happen on the homework assignment that you have. The homework assignment is about you're basically creating a miniature version of Instagram on the homework, and so a lot of things can go into that. A lot of ways that Docker cannot work properly, and so we'll go over that on Friday. In order to follow along on Friday, I recommend that you complete the first 2 sections of the homework file before then. Down here is where the link is, and if you follow that link. Yeah, so that's the project setup right here, and this Docker section right here. It's pretty much stuff that we've talked about in class, just like, I don't know, 2 or 3 screens worth. Make sure that you can have that running, and then the weird stuff starts in this Postgres section. So you don't have to. You're welcome to start on that if you'd like to, but I'll talk about some of the weird stuff on Friday, and all that will be recorded and put on YouTube. So there'll be no assignment due this Sunday, and the homework down here will be due on Tuesday. Historically, students have told me that this assignment takes them about 10 times longer than the previous Docker assignment. So I don't think there's anything like typos or anything in this assignment. I have gone through and rebuilt my version of this assignment, and everything works. So hopefully everything will continue working for you. So the problems are not like I don't know, maybe the super difficult kind of problems. The problems are just that Docker is weird and finicky and breaks easily, and so it's probably going to break on you at some point, and you'll have to figure out why that's the case and debug it. So yeah, 6 days from now. So the next Tuesday that we have. Michigan. Okay, I don't have a solution to that right now. For me, it said it did exist. I'll have to take a look at that, and we'll see what the problem is. You should be able to replace it with a slightly different version number, and yeah. I mean, I can't guarantee that it's okay, but the particular like code here is not using any fancy features of things, so it should any similar version should work fine, I think. The way that Docker container is built, it is specific to a particular version of Python 3. So if you're having a different version of Python 3, so yeah, this is specifically, we'll be using Python 3.10.7. If somehow you have a different version of Python 3, then something's wrong somewhere, and that would explain why the Flask thing is different as well. The question is there a way to update to this version? And the answer is, if your Docker file looks like this, then there should be no updating needed, that it should be that version. If it's not that version, then your Docker file doesn't look like this. Any other questions about like administratively what to expect or anything? Yes. So the part of the question that I'll focus in on is might be a problem, and the answer to that's always going to be yes. So that's not a helpful answer. I think if you have Docker successfully working though previously, then there shouldn't be anything about this thing that's going to break it. So I don't know how helpful that answer is, but that's the answer. Yeah.
So this the is that also in Twitter?
I don't believe so. Yeah, I think he's. Yeah. Yeah, you should still have at least 2 weeks on the Twitter assignment. Which, speaking of which, yeah, if you haven't started it yet, you still have plenty of time. But I wouldn't put it off too much longer because things will pile up, and then you won't have time to do it. So I'd recommend you get started on the Twitter assignments. Okay, today, rest of class, we'll talk very briefly about these notes for the next quiz, which will be on Wednesday. The explanation of what you need to know for the quiz should be very fast. It's just, there's a lot of problems there because there's a lot of weird edge cases that you'll have to think about. And then we'll give a high-level overview of exactly how the Instagram technology works. And that should put you in a good spot to start working on the homework assignments. So this practice quiz is all about what's called the glob in the shell. And the glob is a very useful thing, but it has a lot of very sharp edges on it that, I don't know, so I've been using the shell, using the terminal for about 20 years or so at this point. It's, I'd say like every year I am finding new sharp edges about this glob thing that are making, I don't know, biting me in the butt, doing something bad to me when I discover it. So here, ls, what the glob character does, echo star, anytime you see the star, this is the glob. And what the star does is in the shell, before this gets to the program, the star character never gets received by this program. The shell does what we call expanding this glob character to match all the files in the current directory. So here, this star will get expanded to the if and the quiz.sh file. If I hit enter, you can see the echo has both if and quiz.sh down here. The star can be used in more complicated ways to match patterns. So here we have quiz.sh. If I do q star, then the star right here will match the wiz.sh part, and the q will match the q. And this is the sort of simple, naive understanding of the glob that most people pick up reasonably quickly working with the terminal. But we'll see here all the bad stuff that can happen. And let's see, I will roughly follow the order of things in the notes. Let's reset. Yeah, the first thing I'll do rm star, very common command. I want to remove all of these documents right here, the if and the quiz.sh, rm star, ls, everything got removed because the star got expanded to include these two documents right here. If at this point I do something like, so let's do touch and then hello world, touch, salve mundo like this. So mistyped my Latin. It's salve mundi and hola mundo. How dare I? Now I type ls, there's these 6 files created down here. And if I do rm stars e like this, then the E here has to appear exactly at the end of the file name. So Moonday right here will match, Salve will match, hello will not match because this has the LLO at the end of the file. This only has the E at the end of the file. I do that, type enter, ls, and you can see that the hello document is still here. If I do something like touch star, this star right here will expand to all the files in the current folder, ls, and you can see that the contents did not change at all. If I do again rm star ls, everything's deleted. But now what happens if I do touch star like this? In a good programming language, this star would expand to all the contents of the current folder, and which would be nothing, and so this would expand to nothing. But the shell is not a good programming language. It is an evil programming language, and so when the glob operator does not match anything, then it becomes literally the star and not the empty thing, which would make programming so much nicer. So now that I've done this and I type ls, I have a file that is literally called the star character. I'm going to go ahead, let's do touch A like this and ls. And now I have two characters down here, two files, the star and the A. And what if I want to delete the star file? I could think about doing something like rm star like this. If I do that though, then this star will expand to both this star and the A, and it will delete both of the files. I do that, type ls, you can see both of the files were deleted there because on this line right here, the glob expanded to that and to that. Let's redo this again, touch star, touch A, ls, we have that back. If you want to actually delete a file that is called star, you have to put it inside of quotation marks. The type of quotation marks do not matter, whether it's single or double quotation marks, the glob will never be expanded inside of quotation marks. Glob is never expanded inside quotation marks. Any questions so far? The question is down here when ls is showing this like this, is it always going to put quotation marks around a file that has the glob name? The answer is that in that first lab with the downloading the settings, configuring the shell, one of the settings that you downloaded is something that changes the ls command's behavior so that if ever there's a weird character, it puts the name of the file inside of quotation marks. And that way you can always copy and paste one of these files into down here, and it will exactly reference the file. So you can copy and paste that like that. I just deleted it, so that's why it's saying no such file or directory. If you have something like touch hello world, type ls, you can see it puts hello world in quotation marks because it has the space special character. That's not something that is universal to every shell environment, though. That's something that's specific to how the settings have been configured. Good question. Yes. This is a really good question. So here we have, let me remove the hello world and let's touch B, C like this. We have 3 files down here. And the question is going to be, what happens if I do echo and hello world into star? This is going to be confusing, so we'll step through it step by step. So the bash shell realizes this is confusing and has prevented me from doing it. Bash is actually technically not POSIX compliant right here. So in a POSIX shell, let's start up a POSIX shell dash ps1 equals that. Let's rerun this. See if dash will let me do this. Yes, it does. And let's see what happened. We'll walk through it and then we'll explain exactly why this happened. Dash is also Okay, well, I don't want us to get too far off tangent. The short answer is no, that if you have an output redirection, you can only output to one file at a time. And if there's never a situation where you'd want to have a wildcard to the right of an output redirection. If you're doing something like this, then something has gone very wrong. Yeah, but good question. The way spaces interact with the star is interesting. Hello world, touch, salve mundi. So with for loops, we've seen that for loops, they use spaces as their delimiters for things. And if we had a $ variable, so like bar equals hola mundo, like this, and I do for I in $bar, echo $I, do echo $I. This will loop through 2 times, each time calling echo on one of the individual words over here. Putting it inside of quotation marks makes the loop happen only once. This makes it happen 2 times. And with the star, though, if you have a space in one of the patterns that matches the star, we do not consider those 2 separate things that the for loop will go over. I'll hit enter right here, and you can see that hello world, salve mundi, those happen on the same line. They pass the same thing to echo over here. And because the file name contains a space, so the behavior here is not really what I would expect for how the variables behave, but the order of operations here is that first variables get expanded, then the for loop determines what all of the individual parameters are, and then the glob gets expanded as the very last step. Questions about the for loop? The reason for this behavior is that it usually does the thing that you would want it to do if you have spaces and file names, but it is still a little bit weird. The section in here of 1.3 security, this is a really important one and a really weird one. This is the spot that you're definitely going to have stuff on the quiz related to this section. I'm going to go ahead and do rm star here, clean out this folder. And let's see what happens if I have some weird file names. So one possibility of a weird file name is this -a, like this. That's a weird file name. Echo test into -a. And if I type ls, we can see there is a -a over here. If I type ls star, then normally when we type ls star, or when we type a star over here, what we're thinking of is we're passing all of those files to the program, and the program is going to do whatever it does on those files. But here, what this star is going to do is the star will get expanded as this -a, like that, and then it'll run ls-a, giving me all of these dots, not just talking about the -a file right here. So again, in my folder, I have a file -a, weird file name right here. And when I do ls star like this, it lists the star gets expanded to the -a. This gets substituted right here. And then the command ls space -a gets run. If this is a file, I don't know. I mean, let me do one more example that'll maybe make it a little bit clear why this is weird. If I well, let's think about how can I remove this file now? If I do rm-a like this, then you see that we get this weird error message down here. All I want to do is remove this file. But what rm is doing is it's interpreting this as some sort of command line parameter to the rm program. If I put this in quotation marks, that doesn't help at all. The quotation marks only change how variables get interpreted. What I have to do is put double dashes in front of this, and the double dashes always mean that everything after a double dash is actually a file name and not a like a flag to the program. So rm double dash dash a, hit enter, no error message, ls actually removed the file. If I recreate that file, echo hello dash a like this, type ls, here's the dash a file. We will try ls dash l, we get the extra information about the dash a file. Let's touch b, ls dash l, information about both the dash a and the dash b file. If I wanted to get information about just this dash a file and not the b file, I can't do ls-l-a like this because the dash a will get interpreted as the all, and now it's running ls-l-a. If I want it to actually only give me the information about the dash a, I have to put the dash dash right here, and that tells it that everything after is the dash a. If I do ls star, again, this is, so ls by itself, we have a dash a and a b here. If I do ls star, then all we get is the b over here. This command substitution comes out to ls space dash a dash b, and this command right here only gives me the b, because it's only asking for information about the b file. It's interpreting that as a file itself. If I wanted to get the information about both files, have to add the double dash right here. This becomes, or the weird behaviors happen when you're using the rm command, especially trying to like delete everything in this folder. Why is it not deleting everything? I want to delete everything. How do I delete everything? Then you can either do rm with a dash dash in front so that it does delete everything, or the other option, if we have the same setup, the other option is that if I do rm dot slash star, the dot slash star means that now the star will get expanded into the dash a like this, and dot slash b like this. Dot slash a, this does not get interpreted as a command line parameter. It sees this directly as an actual file path, and we don't get an error message. Yeah, weird behavior. Any questions about that? Reason this is a security thing is that, for example, if you clone somebody's GitHub repository and they have weird file names like -rf, and you try to do rm star, they can make you delete things that you maybe did not want to delete. So good practice, anytime you're using the glob, anytime using the glob in the real world, either put it after a dash dash, so it'll actually get interpreted as a file name, or do dot slash star, and then that'll also force it to be interpreted as a file name. The last part of the quiz here has all of these things combined together with Git. And so it'll be sort of a review of everything with all the weird glob behavior added on. Any questions about? Yes, Kevin. What's the purpose of using glob if what? Question is, what's the benefit of it? So let's ls/data/Twitter data set like this. One of your first, the lab assignments was to count all of the days that we have tweets for. It turns out that there is a zip file for every day, and so you could do something ls*.zip like that, type wc-l, and that was a correct answer to how many days there are in this data set. And so we're using the star to do that. I probably use the star, like, I don't know. Wouldn't surprise me if it's over 100 times a day. Just very useful to to cluster things together. Did that answer your question?
Yeah, so just the same as it's
So the question is, how does this compare to regular expressions? Side note, lots of people here pronounce it regex. Uh, I like regex much better because it's a regular expression. It's not a regular expression. But so with regexes, like in the grep command, in grep we have regexes. And so if we have ls, let's touch A, B, C, D, E. And let's do the hello world. Salve Munde. With the glob, ls star E, then we match everything where E is the end of a file. If we did ls pipe grep star E like this, so here I'm putting it in quotation marks, first of all, so that the star does not get expanded. So the glob does not get expanded, and the star actually gets passed as a regular expression to grep. And when I do that, you see that we get no output because this doesn't match any, this regular expression doesn't match any of these files. The equivalent regular expression would look something like that, which now matches 3 of these same files, but not these one, but not this hello is different over here. With regular expressions, as long as it matches anywhere in the file, then it will return the corresponding line in grep. With the glob, it has to match the entirety of the file name. So this is actually the exact same thing as that. Yeah, they're closely related, but they do behave differently. We'll see. We're going to start working with SQL here in a week after we're done with this Instagram stuff, and we'll see that SQL uses the glob style behavior and not the regular expression style behavior for stars. So some programming languages use the star this way, some use it this way. They're closely related to each other, but not exactly the same thing. Okay, I'm going to switch over to our notes for today, and there's everything else is going to be very high level today. Just giving you some intuition about how why, or motivation for why we're doing this upcoming assignment and how it's going to connect to the rest of the class. And in particular, we'll talk about exactly how all the technologies that Instagram uses under the hood to serve web pages and process their petabytes of data efficiently. So in order to do that, or first of all, I guess this bullet point up here, I have this statement that old or boring technologies are the most useful. And there's this common catchphrase in engineering discussions that you should be choosing boring technologies. And the shell is about the most boring technology that we have in the computer science world. It's been with us for 50 years. And so that's why it has all of these like weird warts that we're learning about, but it's also only getting more popular. There's this thing called the Lindy effect that predicts the future life expectancy of a technology is proportional to its current age. And so you can expect that we'll be using the shell for at least another 50 years. So that's probably the entirety of your careers, whatever you choose to do. The shell will be around. Other big data sort of technologies come and go every year. They don't stick around very long. And there's this fun game, Pokemon or Big Data, where you have to guess is it a name of a big data technology or is it a Pokemon? I don't know. That one, I think it's a Pokemon. I don't know though. It is. Vulpix, that one I know. That one's from the original. Spoink. I think that's Big Data. Yep. Oh no, it's a Pokemon. Oops. Oh, it's only giving us Pokemon. I just want to get one that says Big Data. Come on. Okay, Hummingbird is Big Data. Actually, there's a thing from Twitter. But most of those things, I mean, people talk about them, they put them on their resumes, but the technology exists for like 5 years, maybe 5 months, and then nobody uses it anymore. Bash things are going to be, people are going to be using that forever. So that's why we're spending so much time on Bash. Okay, in order to, we're going to talk next about high level idea of these high availability web servers. And what we're really focusing in on here is the role of the data in the web deployments and how the data is going to be stored. And we'll just after this week, after next week, that's what we're going to spend the rest of the class talking about. And I just want to talk about the web stuff because if we're talking so much stuff about the backend things, it makes sense to spend some time talking about the front end of actually doing something with the data and displaying a web page. There's this famous framework called the 12-factor web app, which is if you're going on to like a systems development interview, people would definitely talk about this and ask you about the 12 factors. Some of these things are things that we've been doing you're familiar with already, like tracking all your code in version control systems like Git. You saw last time with this dependencies that if you're not explicitly declaring all of your dependencies, that can lead to huge problems. And so throughout the rest of the course, we'll be seeing all of these other 12 factors as well. In terms of so this is a very like high level thing that people try to aspire to. It doesn't talk about specific technologies. In terms of specific technologies, the first web stack that was very popular is called the LAMP tech stack. The LAMP stands for Linux, Apache, MySQL, and PHP. So Linux, the operating system, Apache is the name of the web server actually displaying the web page, MySQL is the name of the database, and then PHP is the programming language. We're going to be using Postgres here instead of MySQL. MySQL used to be the most popular one on the internet, but Postgres is surpassing it now. And we'll talk a little bit about why when we get to the database portion of the class. But this, the important thing about this web stack, very popular in the 90s and 2000s, and it's what Facebook was originally written in, entirely in this. Since then, Facebook has their own customized thing that sits on top of MySQL to store the data, but it's basically this which runs Facebook. After the LAMP tech stack, and sort of at the same time, people were using the WIMP tech stack. And the WIMP name is supposed to be evocative that was for wimpy people. And that's because it's based on Windows. So Windows, IIS is the Microsoft web server, still using MySQL and PHP. Just the first top two technologies changed to Windows. At the time, very few people used Windows. Nobody uses it anymore for these sort of things. Even Microsoft doesn't use Windows. If you look at Microsoft Azure, most of their web servers are running on Linux. The only website that I actually know of that uses Windows on the back end is stackoverflow.com, which is an admittedly major website, but I don't know of a single other website that uses Windows in the back end. And even Bing and Outlook.com use various Unixes to run their servers. WIMP, this tech stack really became famous because in 2001, right at the same time that the September 11th attacks happened, there were 3 major vulnerabilities in Microsoft Windows that caused the internet to actually shut down. Each one of these took the whole internet down for about a week. I remember trying to play Age of Empires with my friends and I couldn't do it because of these problems with Windows and IIS at the time. So one of the reasons people have switched over to Linux is because this tech stack just has a reputation as being not very secure. So Instagram came around kind of right after the LAMP tech stack's heyday in the late 2000s, early 2010s. And their tech stack is what they originally deployed with is essentially what like the standard startup web tech stack used today. And so we're going to follow that in our class. They have a detailed write-up. Instagram has a really good engineering blog. I would definitely recommend clicking on this link at some point and reading it and seeing things from their perspective. But so their tech stack has these 4 web server or these 4 services as their main components. This program up here, I pronounce it Nginx. The developers pronounce it Nginx. That seems a little bit too cute for me. This one, everybody pronounces the D out front, so it's Django, and then PG Bouncer and Postgres. Postgres is the actual database. Django is the Python program that actually generates the HTML. Nginx is sort of a server, and PG Bouncer is something that helps this database. This image right here is how all of these systems work together. So when you're on the internet and you connect to Instagram, you first connect to this Nginx program. It's again this like web server load balancer thing, and what it decides is which one of the web servers that Instagram currently has running you're going to connect to. Each one of these boxes are a Docker container that's existing out in the cloud somewhere. When Instagram first started, they were on AWS in the cloud, but after they were purchased by Facebook, they've since migrated all their web hosting over to internal Facebook things, I believe, at this point. So all these things now hosted in Facebook data centers. These web servers are what we call stateless applications, which means that if every time you connect to Instagram, you might be connecting to a different one of these web servers, and the web server is not allowed to like remember anything about your connections. It's not allowed to remember who you are or what web pages you've been looking at. It's only allowed to respond to your immediate request. And what that does is that it allows Instagram with their Docker tools to say, okay, currently we only have 10,000 people connecting, so we need 4 web servers. But then since they now have a lot more than 10,000 users, maybe they have 10 million people connected now, and so they just have more web servers down here that have scaled up their servers. At the time in 2011, this is, I believe, the last published report they have of specific numbers. They had 25 different computers running different web server applications on them, all running the exact same code, and then this load balancer Nginx thing just deciding which web server you're actually going to. If these web servers are stateless, so they can't remember any information about the user, every time you connect, every time you click a button on Instagram, no matter which web server you're at, it's going to contact the database in order to get information about what it should actually display to you. And that database is, again, this Postgres system. At the top of the database, there's another one of these load balancer things that decides which of the database servers your connection is going to go to. And then there are several database servers that are storing the actual information themselves. The database servers, having multiple database servers is a really, really complicated task. We are probably not going to get to in this class talking about how to have multiple database servers coordinating their information with each other. Instead, we'll have just a single database server, which is a very large database capable of storing lots of information. It's a super high level overview so far, but any questions at this point? Okay. So this Nginx thing, it is currently the world's most popular web server. If you click this link over here, here's the web server survey report. Every time you connect to a web server, it tells you what web server you're connecting to. So it's really easy to gather these statistics. So as of, I guess, about a year ago, August 2022, this dark line over here, Nginx was the most popular. So very widely used. It's very efficient, easy to incorporate with Python. Again, Instagram uses Django because that, at the time, was the most popular Python framework. It's still moderately popular, but Flask is definitely a lot more popular these days. It's a lot easier to work with. So that's what the tutorial will use. Uses Flask to do all the Python programming. And it turns out that both of these two things and a dozen or so other Python frameworks use this thing called WSGI. So this is this WGSI is pronounced like whiskey, the web server gateway interface. It gives them a common interface so that they can have Nginx using like their actual web server. Maybe we'll do one fun anecdote, end on a fun anecdote today. The reason Flask is called Flask is because a flask is the best way to drink whiskey, according to the author of the library. And so the best way to use the WSGI interface is the Flask library. Hopefully that'll give you enough background to complete the first few steps of the homework. And then again on Friday, we'll go over like some more of the technical details about the homework so that you'll be able to have an easier time overcoming those obstacles when you get to them. Happy to stick around and answer questions after class, but that's it for today.